Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Welcome to episode 58 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. This is a special podcast. We're interviewing Don Machholz, who just recently discovered his 12th comet, so hang on to that. I'm Tim Robertson, the host of the Observer's Notebook and also the coordinator of the training program within the ALPO. I want to thank you for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomena, and they publish detailed reports concerning these bodies in its quarterly publication known as the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear on the podcast, you can donate to it via Patreon. You can give as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook, the official handbook of the training program. And for $35 a month, you receive 1 year's membership to the ALPO and producer credits on the podcast. You can help us out by going to www.patreon, that's patreon.com/observersnotebook. If you'd like to join the ALPO, you can for as little as $18 a year. For more information, visit us on the internet at www.alpo-astronomy.org. And we're also on the Facebook. Search for ALPO Astronomy. If you search for ALPO, you'll get dog food, so you don't do that. And yes, the Observer's Notebook also has a Facebook page. Just search for Observer's Notebook. If you enjoy what you hear on the podcast, please subscribe. That way you'll never miss another episode of the podcast. And now, the Observer's Notebook. All right, I'd like to welcome everybody back to the Observer's Notebook podcast. Today we have a return visitor to the podcast from episode 42. It's Don Machholz. Welcome back, Don.
Well, thank you, Tim.
In the previous podcast, we talked about your 11 previous comet discoveries, and you're on today to talk about your 12th that you've discovered, I believe, on the morning of November 7th?
Yes, that's correct. Wednesday morning, November 7th.
Yeah, before we get into it, why don't you just give everybody a little bit of background about yourself if they don't know who you are or they haven't heard the previous podcast?
Well, I'm an amateur astronomer. I became interested in astronomy at the age of 8 and got a few small telescopes as a boy. Did all the Messier objects in 1 year with a 6-inch reflector in 1968, 1969. Was in the military for 3 years, and when I came out, decided to get involved in a program which would keep me looking at the sky, because I enjoyed the view of the night sky through the telescope. And I chose comet hunting. And I began a systematic program of searching for comets on January 1st, 1975. And searched the sky, both the evening and the morning sky, for many years. And have done so ever since. 527 consecutive months of comet hunting, of at least 1 hour of comet hunting each of those months. In the course of that time, I've now picked up 12 comets. The most number of hours for me to find one of them was 1,742, and the least it was about 30 or so. I found a comet in 1978. I found my second one 7 years later in 1985. That was found at the Riverside Telescope Makers Conference.
I do remember that.
Yeah, I remember that. In 1986, just a year later, I discovered my third comet, which is a periodic comet known as P96. It's a very interesting comet and goes very close to the sun every 5 years. And then 2 years later, 1988, in August, I found my fourth comet. Those other three that were not found at Riverside Telescope Makers Conference, the other three were found at Loma Prieta which was in the Santa Cruz Mountains. At that time, I was living in San Jose in the Los Gatos area, about a 40-minute drive from Loma Prieta, so I would commute, especially in the mornings, to go out and comet hunt. I then moved to the Colfax area, Colfax, California, which is about 45 miles north of Sacramento, in the foothills at 2,200 feet elevation, right off of Highway 80 here, and resumed my comet hunting from here. And from this location, I discovered 2 comets in 1992, 3 comets in 1994, 1 more in the year 2004, 1 in 2010, and 1 just a few weeks ago.
Now, what equipment did you use to discover this comet?
This one was found using an 18-inch reflector, an eyepiece giving me a lot of magnification, 113 power. It's a 100-degree eyepiece. And field of view, the actual field of view is about 58 arc minutes, or it's just under 1 degree. And the focal ratio of the telescope is f4.8. It's mounted as a Dobsonian telescope, and so the major movements are up and down, left and right. And I was moving it left to right when I discovered this comet. I usually sweep in that direction.
So you were in the Colfax area when you made this discovery?
Yes. We're still living in Colfax. We have bought properties in Arizona. We're having a house built in Arizona. It will be finalized in another 3 weeks or so. We've been moving our stuff to Arizona, so more than half my stuff is in Arizona.
So you're part of that great California, get the heck out of here and go to another state.
You're right about that, Tim. Yes, that's correct.
Your reasons might be a little bit different than most, though, probably darker skies, maybe?
That's one of the reasons that my reasons are probably like most people's reasons, too.
Right.
I mean, this is California, and Arizona is different than California.
This is very true.
So we're fixing up our house to put it on sale. I've been doing exterior painting. I had to rebuild 2 decks. Then we do the interior, and probably in 3 or 4 weeks we'll have it on the market. And it includes the observatory, but as our real estate agent has stated, and I was a real estate appraiser for 15 years, and I see this to be true. People don't usually buy an observatory for the use of using it as an observatory. And more than likely, the person who buys this house, unless they're an astronomer, the observatory will become a hot tub building or storage, or they'll just remove it. That's too bad, because it's a good place for astronomical observation. We've cut and trimmed all the trees. It's got fairly dark skies, good weather, and I've discovered 8 comets from this location. But,
you should put a plaque on it, make it a historical site.
Yeah, well, that might actually decrease the value, because the new owners would have people coming by to look at it, and they wouldn't be able to make any changes to it. So I'll put out announcements, even at Riverside, that this property will be available, but only one person has responded, and they decided to buy something in a different state. So it's still available if any astronomers wish to purchase our property. It's got a house on it, 3-bedroom, 2-bath, with a garage and the observatory on 6 acres. So.
All right. Well, I'll put your contact information. If you want your real estate information on here too, I'll put that on the podcast as well. Now, listening to you, I've talked to you before many times, and you always know the exact number of hours it took you. I mean, you must take copious notes and really detailed notes of your observations.
I do. And I record when I begin comet hunting and what location I begin at using the electronic setting circles. So in this case, I began, I might even have it here in my notes, but I began at the equator and about 8 or 10 degrees above where the comet eventually was found, and swept to a minus 15 degrees declination. This was an area I had not covered. Late October, we had great weather. I got out quite a bit and covered a lot of the morning sky, the areas that are not covered by the big search surveys. And I had worked my way down to this part of the sky. Then we had almost 2 weeks go by where we had the moon in the way. We had bad weather. I went out on November 6th and covered an area to the north and another area. And then on the 7th, I went out and started covering this area. I also keep track of what objects I see, all the galaxies and so on. That gives me some idea, if I wish to look back at it, to see how deep I went, how faint I was able to see. And it gives me also some idea of what I actually saw. So that if we later learn, a few weeks later, that there was an undiscovered comet in that area that was later discovered, we trace them back and see where they were. If, in fact, I had mistaken it for a galaxy or something like that. Now, that's never happened, but I would know if I had done that because of the notes that I take. I also record the number of satellites I see through the eyepiece and the number of telescopic meteors I see through the eyepiece.
I would love to see your... Is it electronically you keep it now, or is it all on notebooks?
I write it down in a notepad while I'm out at the observatory, and then usually near the end of the year or every 1 or 2 years, I put it onto an electronic, an Excel spreadsheet. The telescopic meteor information I've accumulated now for 45 years. I have been in the process over the last 10 or 15 years of putting it all on a big Excel spreadsheet. It would be probably the largest database of telescopic meteor observations ever compiled. I'm now retired, but we're in the process of moving. After we get moved in, I'll spend part of the next year finishing that up.
That sounds... to do what you've done, you've got to know the sky really well, and you have to have taken really good notes to cover everything. That's really dedication to this type of observing in the hobby.
Yes, it's important though, and I keep track only of the amount of time I'm actually looking through the eyepiece. That's kind of important because when you record the number of telescopic meteors you see, you also record how much time you spent observing. So if you're not looking through the eyepiece, it shouldn't count as time observing. So I only record the time I look through the eyepiece, which is about 85 or 90% of the time I'm actually there from beginning to the end of the session.
Now, do you have a plan when you go to the eyepiece for, let's say you're going to go out tomorrow morning and look for comets? Do you know ahead of time where you're going to look and how much time you're going to spend?
I know about how much time I'm going to spend, and what I do now, what I've done for some time, is to pull up a planetarium program. I use the sky, and I see what the sky will be like. For instance, tomorrow twilight will be about 5:40. If I were to go out at 4 o'clock, I'd pull up the sky at 4 o'clock. I'll print out a map showing the morning sky from beyond the North Pole, a little bit toward the west of the north, all the way to the south, but mainly the eastern sky. I then go to the sky coverage charts, which are available from Central Bureau of Astronomical Telegrams. You can go on their website, and you can see what parts of the sky has been covered by the big search surveys. And I'll write on the map the boundaries of how far they've gone toward the solar region. Usually they stay 40, 50 degrees away from the sun. So that leaves that area for me to visually search. I also look at what I've covered recently. If I've been out there covering an area within the last 2 weeks or so, I usually do not go back and re-sweep that area. I'll find there's other areas to sweep. And so when I go out there, I know about where I'm going to start, about how high in the sky it will be, and how much time I'll have to be able to cover that area. I sweep about 15 degrees in declination for each section of the sky that I cover. But because it's an azimuth mount, it's probably a 19 or 20 degree actual sweep, because I'm not going right down the right ascension line. I'm going at some angle to it because it's an alt-azimuth mount, not an equatorial mount. That takes me about 2 minutes, 2.5 minutes. I like to have a lot of low overlap. So normally, as I get to the end of the sweep, I pull the telescope back toward me, and then either sweep again at about the same altitude. And now the sky has moved over the last 2.5, 3 minutes. And so I have new sky I'm covering. Or if I'm going a little bit more quickly, I'll drop the telescope down a quarter of a field, a fifth of the field, and then sweep again. And I sweep in a continuous motion. I don't just stop at each field. I just keep it continually sweeping. And the eye and the brain are very busy looking in the field of view for fuzzy objects.
Now, you've done this, you said, for 45 years. So you must know the area of the sky that you're surveying pretty well mentally. How often do you have to go back and refer to a star chart when you see a faint fuzzy?
Well, I do that more than one would think. Until I got the 18-inch telescope, I was using a 10-inch f4 reflector and the 6-inch homemade binoculars. And in each case, I could get down to about 10.5 or 11.5 magnitude. And I had learned what things looked like in those wide field of views, which were like 2-degree field of views. And I knew the star patterns around the galaxies and stuff, so I could recognize those right away. When I switched over to the 18-inch telescope with a field of view of less than 1 degree, I was able to pick up objects that are a couple magnitudes fainter. And so now I pick up a lot more objects. I have electronic setting circles with a computer box by the eyepiece, and I align the telescope prior to each session, and I put it on the search mode so that anywhere in the sky that it is pointed, if there's a galaxy or cluster in the area, it will say so on that electronic box. If there's nothing there that it knows of, it will give you the words searching data. That means it's searching through its database and hasn't found anything there.
That makes it a lot easier for you than because going to a larger telescope, obviously, your knowledge of what you would normally see has changed.
Yes, and when I pick up a comet or I pick up a fuzzy object and it says searching data, as it did on November 7th, the first thought is this is not a known galaxy or cluster, or else it would say so. The other option would be it could have misaligned somehow or be off by a little bit. But on November 7th, I had picked up a few other galaxies, and it was aligned properly in telling me those galaxies were there. Now with the 18.5 inch, I'll pick up galaxies and I'll scroll over and on the computer output box and see that it's, say, 11.8 magnitude. And I would think, well, it seems kind of bright for 11.8. You see, you don't want this to happen as a comet hunter. You pick up a fuzzy object and you look at the display and it says galaxy, 6844. So you say, oh, okay, that must be that one. But if you hit the magnitude button, it tells you it's like 13th magnitude, and the thing you see through the telescope is the 11th magnitude, then maybe it's a comet, and you're not seeing the galaxy because it's too faint, but there's a comet there, and it's in the same location or close to the same location within 0.5 degree of where the galaxy is. So you don't want to be fooled by that. So once in a while, I'll pick up a galaxy, and it will say it's like 12th magnitude. I think, wow, this thing seems a little brighter than 12th. Or 12.5, and I'll pull out my star maps, Metria star map, and see if it's on there, and see how it aligns with the stars, just to make sure I have the galaxy. So yes, I do that from time to time.
Now, what is that device that you're using that's next to your eyepiece that you can just hit a button and see if there's an object in that area?
It's called the Sky Commander electronic setting circles. And I bought it shortly after I got the 18-inch so that I could track where I am.
Sounds like that's pretty interesting. helps out in your search.
Yeah, there's several units out there that do that. I mean, different types of digital setting circles, but this is the one I use. It's made by Sky Commander. And it seems to be fairly accurate, assuming you have to do the initial setup of putting what's known as decoders onto the two axes of the telescope. And if that's done properly, then it will work. We have other instruments that we're taking to Arizona with us that we will experiment to see how they would work for comet hunting under the darker skies. And it's possible I'll be buying additional units of the digital setting circles and outfitting them with setting circles too, but we'll see.
Okay. Now, it's a visual discovery, and these don't happen anymore. With Pan-STARRS and the other sky catalogs and surveys that are out there, you're in stiff competition, but you said something interesting a little earlier, that you look at the limit of how far south or how close to the sun that these surveys go, and you don't go there. You don't go where the surveys go, correct?
Right. It's they go very deep. They usually go to 18th, 19th, 20th magnitude, and a comet that's that faint is going to take months to brighten up. Typically, to brighten up to where we can see it. So they've covered that area. There's probably no comet in those areas that I would be able to pick up down to 12th magnitude. There's exceptions. A comet can be found in any part of the sky at any time by anybody. That's one of the first rules of comet hunting. And a comet that is passing close to the Earth, which is intrinsically faint, could miss everybody and be near opposition for a few hours, moving a few degrees an hour. And, everyone can miss it except for someone out there visually. But that's not likely to happen, so I don't spend my time going deep into the opposition area where they have covered. In fact, they quite often cover an area every few days. So anything that would have brightened up rapidly or outbursts, they would have picked up. But there is some sizable areas that they do not cover. They don't usually go very close to the sun. And especially in the morning sky, we do have comets that whip around from behind the sun, behind the solar vicinity, while they brighten. They're moving in toward the sun. And then once they reach into the darker parts of the sky where we can reach it, they're bright enough for us to see. And this one did something like that. In fact, on October 22nd, I covered an area down to the equator, from 15 degrees north to the equator. The comet was at about a -3 degrees south, but I also stopped about 4 or 5 degrees from it. And it was a little bit south of where I was covering, and it would have been around twilight. And it was October 22nd, so it would have been a bit fainter. So I might not have picked it up, even if I had swept a little bit further south and continued sweeping.
What was the magnitude of the comet when you discovered it?
It was about 10.5 magnitude. In fact, that was the most surprising thing about this discovery. I'm sweeping along, I'm picking up some faint galaxies, and a fairly bright object appeared in there. I did not have to look twice. It was there. It was there with direct vision. It was there with inverted vision. It was obvious. And I thought, this is pretty bright. I'm not sure I know of any galaxy here. Let me look at the Sky Commander. I look up and it says, searching data. That means there's nothing that it knows of in that area. So my next thought was, well, could it be a known comet? And there's a popular website that lists all the comets that are visible. And I have my smartphone with me out there at the observatory. And so I went to that website and I had the approximate right ascension and declination, the position of this object. And I searched through the database of what was visible, and nothing was at this area. So I knew pretty quickly this is a comet and it has not been officially confirmed or discovered. I then got the Unimetria star atlas out, turned to that page, and there was nothing there. So I put a little X where this object is because I'm going to have to measure the position later. And also then, shortly after that, I made a more detailed map so I could check for motion. I then went back to my smartphone and checked again to make sure I didn't miss anything. And then I called my wife and asked her. I used our phone. I used a cell phone. And I called her. I said, I think I found something. Can you come out and look at it? And she did. She saw it, and I checked for motion. Over the next half hour, it did move a little bit, and I recorded that. And I tried the Swan band filter. Now, this is a optical filter you put between the eyepiece and your eye, and it's sensitive to gaseous comets. A gaseous comet would appear to be more prominent with this filter than without it, and it was. So I thought, well, it looks like perhaps a gaseous comet, and it's moving, and it's not known. Now, the only other question is, has someone found it within the last half day or so, and either put it up on the confirmation page, or not yet reported it? So I then went into the house after twilight had begun and it was no longer visible, and went to the International Bureau of Astronomical Telegrams, their website. You can see if there's any known comets down to 20th magnitude in that area, because maybe one has outburst or something. And there was nothing there. And there was nothing on the confirmation page. So this looked like a new object. So I went to their website to find out how to report this thing. Back in the old days, I could pick up the phone and call Dr. Marsden. Prior to that, I would send telegrams. Well, those days are gone. Dr. Marsden's passed away. So it said you had to send an email to the Minor Planet Center for discoveries. So I sent them an email. And I gave the position and magnitude, when I saw it, who I was, what instrument I used, and that it had moved. And I also found Daniel Green's phone number. He works there, and called him and left a message. He wasn't in yet. And then I began to look for someone who could confirm it. Gareth Williams of the Minor Planet Center rather quickly sent back an email in response to my email to him, and he said, confirm it. And, well, it's already light here. I've already seen motion. Probably the best way to confirm it is to wait till the next morning and see it again and get a second position. And that usually makes them happy enough that they will put it on the NEO confirmation page, Near Earth Object Confirmation page. Once it's on that page, it's publicized to the whole world, and anybody can go out and confirm it. But I also thought I would try to find other people who could confirm it. Those in Australia and New Zealand were still in darkness, and it was still pre-dawn for them. And so I don't have phone numbers to amateur astronomers there, so I began emailing a few in Australia and New Zealand to see if they could do it. Steve O'Mara used to live in Hawaii, so I wrote him an email. And nobody answers their emails at 3 o'clock in the morning. So I didn't hear much until finally Steve O'Mara says, I'm not in Hawaii anymore, I'm in South Africa, or Africa. So he wasn't able to confirm it, and it was a little bit low in the sky for him the next morning. So he said, that position I would not be able to confirm it. I tried astronomers in Europe, and no one was really able to confirm it. So Daniel Green called me, and he said he would get one of these search surveys to look for it from Arizona the next day. And I contacted Howard Brewington, who had discovered 5 comets back in the 1990s. and 80s, and asked if he could help confirm it, and he said he would try to do that the next day. My wife got a subscription to SLU, which is an automated camera system on an internet served, and it's in the Canary Islands. So we reserved some time at 9 o'clock that night for the comet, but we had the wrong positions. I was thinking it was moving one direction, it was moving a little bit different direction. So, and we didn't know how fast it was moving, and it was actually moving more than a degree a day. So we missed it with those photographs. Otherwise, we could have picked it up about 9 o'clock that night, which would have been about 15 hours after I first saw it. Meanwhile, in Japan, I was checking the weather in Japan. You can do that on your smartphone. And partly cloudy in some parts of Japan and rain in other parts of Japan, and there was a storm system moving through. So I thought, well, that would be the next group of people who would be able to discover it. And Japan has some very competent and experienced comet hunters. And they did pick it up. There were 2 Japanese comet hunters who picked it up photographically or with CCDs. And they did not announce it to the Smithsonian the same way I did. They went through a different website, a web page that they have for transient objects, which would be like gamma ray burst and nova and things like that. And it's my impression that the Smithsonian did not know until hours later that they had been reporting this object. Now, they saw it after me, and at the time it was confirmed by the search survey in Arizona the next day. Word was just getting to them that these other 2 guys had also seen it. They were going to, if they had not found that out, it would have been just known as Comet Machholz without the other discoverers. But their word became very public, and the position became very public when it was put on that transitory object page. And then other people could look there too. The Smithsonian likes us to keep the position of the comet quiet until it's confirmed. And that's because if I say I found a comet at such and such a position and it's not confirmed yet, someone else can go out and say they saw it just before me and come in with make up some similar position. And it gets very sticky then determining who saw it first and who's telling the truth. Right. So we have to keep the position quiet. We can't publish it. The only 2 people I sent it to were those down the line around the world who said, yes, I can confirm it for you. I'm willing to do that, and I'll have clear skies tomorrow. Then I said, okay, here's a position. And Steve O'Mara says that's going to be too low in the sky. Someone else said the weather's turning bad, so I can't do it. So we have to keep all that quiet. But when this report from Japan was put on that page, they gave the position away and everything on it. So that's why we don't report it that way normally.
So after 11 previous discoveries and 8 years since your last one, what was the feeling? I mean, just hearing you describe, you got excited talking about the different steps you went through, calling your wife and everything else. What was the feeling you had when it clicked in your head that this is a new comet?
Excitement and some surprise. I know I go out there searching for comets, and you kind of have to expect that you might find one when you search. Otherwise, you won't be out searching. But to actually find one and find one that bright was a bit of a surprise, and I was excited about it. Wow, you never know when you'll find your next comet, and under the conditions we search for in now, that it can be 10, 15 years before the next one. But here it was just 8 years after my previous discovery. And here I had picked up a new comet. I was interested in the orbit as to how it got through the search surveys without them finding it. And yes, it did come in from kind of behind the sun. It has a retrograde orbit that's highly inclined, so it goes around the sun in the opposite direction we do. Came in from the south, kind of goes north, and then it will be heading south again. And because of those positions, it kept it kind of in the pre-dawn, pre-twilight sky as it gradually brightened. There's some possibility it could have brightened rapidly prior to discovery, because since discovery, the brightness seems to have stalled, or at least since a week after discovery. I've observed it every clear morning I can. I last saw it now about 5 or 6 days ago. We've had rain since then. And it's still at about 8.5 magnitude. It brightened within the first few days after discovery from 10.5 to 10 to 9.5 to the low 9s. And then most observers are picking it up at about 8.5 or plus or minus half a magnitude or so. It should be normally a normal comet would brighten up as it continues getting closer to the sun, and this one has kind of stopped doing that. There's some talk it could disintegrate. It will be going about 4/10 of an astronomical unit from the sun, which is 4/10 of the distance from us to the sun. So it goes fairly close to the sun, and we've known from the past that if a comet is not of a certain substantial size, as it gets close to the sun, they can disintegrate. And this could do that or may not, we don't know.
Are you familiar at all with the co-discoverers, with Fujikawa and Iwamoto? Do you know them at all? Have you talked to them?
I haven't talked to them, but Fujikawa's been around for a long time, and his comet hunting has paralleled mine for many years. He quite often used large 6-inch binoculars back in the late 60s, 70s, 80s. He's found several comets visually. This is the first one he's found photographically. So sometime in the last 10 years or so, he has switched from visual comet hunting to photographic comet hunting. And I think a lot of the visual comet hunters, if they're still doing comet hunting, are now doing it photographically or with CCDs. And the other comet hunter photographically found one a few years ago. And so this is a second named discovery. And again, he did it photographically this time too.
Okay. Now, perihelion is December 3rd, I believe?
Yeah, so the closest to the sun on December 3rd. And I think we probably had today was probably the last morning we would be able to see it in the morning sky. It's only 19 degrees from the sun right now. And that would have been difficult. I was prepared, but it was cloudy. It will be going into the evening sky, probably beginning around December 5th, 6th, 7th. We might be able to pick it up very low in the evening sky. It doesn't get very high in the evening sky as it moves slowly southward, but it will get dimmer as time goes on.
Hopefully it survives perihelion.
Hopefully it does, yes.
That'd be good. Wow, Don, I just want to say congratulations. I mean, to discover 12 comets visually is a feat, and especially with the competition you have with the sky surveys, that's just remarkable.
Well, thank you. Thank you very much, Tim.
Is there anything else you'd like to add about the comet discovery or anything else?
Well, I'm 8,400 hours exactly since I began comet hunting. 8,400 hours. So lots of time at the eyepiece, but I continue to enjoy it. I enjoy the challenge. I enjoy the strategy. And when we move to Arizona next month, I'll still be comet hunting there, but under a bit different conditions. The horizons are lower. I'll be at 4,600 feet compared to 2,200 feet here in Colfax. Weather's a little bit better. I think the transparency is better. Light pollution is less. and I'll have a little more time to spend covering a little bit more of the sky and then re-sweeping parts of the sky. And as I said, we do have some instruments. I mean, the 10-inch reflector that I used for 4 of my comet discoveries, wide field of view, but maybe under the darker conditions, it might still be a viable comet hunting instrument also. Has a wide field of view, and if I can go deep with it, I can cover parts of the sky with that too. So a lot of things in the mix as we move to Arizona, and I'll continue my comet hunting.
Whereabouts in Arizona will you be?
Kind of like northern Arizona. The closest town is a small town called Wikia. It's near Kingman.
Okay.
From Flagstaff, we are southwest about 100 air miles or so. And off of 93, we're about 20 miles on a dirt road east of Highway 93, north of Wikia. We are off the grid. We have 160 acres there. And it's a fairly isolated place, actually.
Fantastic. Well, it sounds like you are really getting away from California.
Yeah, we are getting out where it's dark. I mean, that's what you need to do if you want to continue comet hunting and do other astronomy too.
Well, Don, again, I want to thank you for coming on the podcast, and I wish you luck in finding 13, 14, and 15.
So thank you. Thank you very much, Tim.
Well, that'll do it for this episode of the Observer's Notebook podcast. Again, I want to thank Don for coming on the podcast and talking about his 12th comet discovery. We upload a new episode of the Observer's Notebook every few weeks. You can subscribe to us on iTunes. If you do, please rate and review us. I really appreciate it. You can also listen to us on iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, and Amazon Echo. You can help support the podcast by donating to it via Patreon. You can give up to $35 a month or receive 1 year's membership to the ALPO and producer credits on the podcast. And with that, I really want to thank Steve Siedentop for his generous continued support of the Observer's Notebook. Thank you very much, Steve. The link for Patreon as well, link for the ALPO, is available in the show notes. You can contact me via email at cometman@cometman.net or on Twitter at ObserversNBPod. If you want to join the ALPO, membership begins at only $18 a year. Find out more at www.alpo-astronomy.org. And we're also on the Facebook. Search for ALPO Astronomy or search for Observer's Notebook. Until next time, my hope is that you always have clear and steady skies. Thank you for listening.